Happy April 28th, everybody. Mr. Rhodey here, just checking in again to see how you're doing. We're going to continue to work with sine, cosine, and we're going to add in tangent today. Think about all these angles on the unit circle, understanding radians a little bit better. And so if you have your unit circle, you're going to want it out today to reference. A lot of these questions you'll be able to answer just by looking at the unit circle or reinterpreting it. But also I highly recommend almost rebuilding it as needed for specific examples. And so you'll see that as we go through today, but having that out is going to be super helpful. Hope you watched again where the unit circle came from. It all still comes back from the SOHCAHTOA ideas in geometry. And understanding the ratio of the sides of the triangles that are built depending on where you stop on the circle. So let's go ahead and dive in to sine, cosine, and tangent. As a reminder, here's our word wall summary, which you should have probably as your own sheet of paper or notebook. We've taken down these takeaways, this idea of converting between degrees and radians, the common angles that you would look at, knowing 180 is pi, 360 is 2 pi, and so forth. And using, I would say the unit circle is really part of the word wall now as well. So we're going to start with a quick, easy reminder of how do we use the unit circle to find some of these common values. So sine, cosine of 90 degrees. Remember, 90 degrees on our circle is basically going to start going to the right and then go straight up. So on the unit circle, that's at 0, 1. Remember, the x-coordinate is cosine of whatever angle I'm looking at, and the y-coordinate is the sine value of whatever I'm looking at. So the cosine of 90 degrees is equal to 0, and the sine of 90 degrees, the height of the sun, right, is equal to 1. Everything that lands on one of these key values using +1, -1, and 0 should be pretty straightforward for you. So let's keep on going. You can pause or skip ahead to try these on your own and then come back to the answers if you so wish. But I'll walk through another one here. 180 degrees is going to wind up all the way over here at -1, 0. So therefore the cosine of 180 degrees equals -1, and the sine of 180 degrees equals 0. I would say the most common mistake is just forgetting that cosine is x and sine is y. It's really easy in your mind to flip-flop those, so just slowing down, taking a deep breath, and being careful. Okay, the next one has us do all three of these, so go ahead and hit pause, try them on yourself, and then I'll reveal the answers here momentarily. Okay, so on try these, letter A, sine or cosine of 270 is 0, sine of 270 is -1, based on having that location 270 degrees rotates all the way down here. -270 degrees, good reminder that negative angles rotate the opposite direction, and I actually wind up here. So notice -270 is actually coterminal with 90 up above. So the cosine of -270 and the cosine of 90 are both 0. The sine of -270 and the sine of 90 are both +1. So again, that's kind of nice to see those coterminal angles lining up. And 720, rotating twice around, it's coterminal with 0, 360, etc. I get cosine of 720 equals 1, sine of 720 equals 0. The next problem in try these B, where I'll pause for you to try on your own, again, is these same kind of major angles, but with radians. So just remembering where those fall on the unit circle. I'll go ahead and pause, and then you can see the answers after you try them yourself. Okay, and here are the answers to the try these letter B. For pi, cosine of pi is -1, sine of pi is 0. You could have looked on your unit circle for these, right, instead of drawing them out each time. But what I've stressed with students over the years is that drawing them out every time just helps you remember where are they on the unit circle. It does a lot more advantage than just getting the answer. It helps make you familiar with how the numbers work for when we graph these later. For 2 pi, I go all the way around the circle, so cosine of 2 pi is +1, sine of 2 pi is 0. Again, cosine being the x, sine being the y. And for -pi/2, I rotate in the downward direction. So cosine of -pi/2 is 0. Sine of -pi/2 is -1. The more interesting stuff starts to happen once my angles don't land on one of my axes. So let's take a look at sine and cosine of these various values. Probably walk through one or two of them with you, and then from there let you practice them as you go. So Here it's asking for both the sine and cosine of 300 degrees. You could look at your unit circle and answer this pretty quickly if you want, but again, we're trying to build understanding. So drawing it is what I'm going to recommend for your approach, and then over time you'll get better at either picturing this in your head or referencing the unit circle as needed. But again, you don't want to have that unit circle always be the only way you figure it out. So for 300 degrees, I realized pretty quickly, it's rotating all the way around, but I am 60 degrees short of the x-axis again. So this would be 300 degrees. That leaves me with a reference angle of 60 degrees in here. And I'm trying to figure out what would that sine or cosine be. Okay, and again, we can build this off of SOHCAHTOA. Remember, we know our hypotenuse is 1 because it's on the unit circle here. And then we have those special right triangles we learned about, the 30, 60, 90 triangles, where like hypotenuses are longest side, and the side across from the 30 is just going to be half of our hypotenuse. So I know that the side here is half, so my x-coordinate is going to be a half, so positive half. This also matches up with the unit circle. And then across in there is bigger. But if I did Pythagorean theorem, we know by now the common numbers that come up, it's going to be root 3 over 2. And in this case, I'm down in the lower quadrant, so it's going to be negative root 3 over 2. I'm in quadrant 4 there, so a positive x value, a negative y value. So my cosine, depending on what order you want to write in, the cosine of 300 degrees is equal to 1/2. And my sine of 300 degrees is equal to negative root 3 over 2. And so that can become something that we use the unit circle for reference for 300, or other angles that end at 300. Or you could simply draw the special right triangle every time, or use the Pythagorean theorem. But these common numbers of half, root 3 over 2, and in our next example, root 2 over 2, are going to keep coming into play. So let's take a look at that next one. 225, negative 225. If I draw a quick picture of that, I know it's going negative 180 and then another negative 45, so I'm right in the middle, splitting the middle there. I know that this is a 1. I know that my reference angle, so this is negative 225 overall, so it's 45 degrees for that reference angle, so it's creating that 45, 45, 90. So I actually know I've got equal sides on this isosceles triangle. So x and y are the same value. X squared plus y squared equals 1 squared, or 2x squared equals 1 squared. We've done Pythagorean theorem with this before, and what we saw in our previous lessons is that's always going to be this root 2 over 2 value. It's bigger than 1/2, but smaller than root 3 over 2. So again, because it's between the 30 and 60, 90 degrees, that helps me. I'm in quadrant 2, so the x value must be negative, the y value is positive. So again, this point here, if you look at your unit circle, this is coterminal with 135. It's at negative root 2 over 2, comma positive root 2 over 2. Therefore, the cosine of negative 225 degrees is equal to negative root 2 over 2, and the sine of negative 225 degrees is equal to positive root 2 over 2. So my hope is that given any angle that would end on one of our common things on the unit circle, you can go and find the sine and cosine for it by drawing it or using your unit circle for reference. And it shouldn't matter if it's in degrees or in radians. So at this point, I'm probably going to jump to the tangent values, finding those, and then you can come back to these later if you want to see more examples worked out, but I'll probably put those at the end of the video so that they're there for those of you that want them, and for those that feel good after 1 or 2 examples, you can jump right in. So let's take a look at what the tangent ratio is. So again, I'm pulling a lot of this from the 32-2 section of your notes, of your book. And so I want to start off with just a big picture of this tangent angle. So if we think back to geometry and trig, we had SOHCAHTOA. Sine was the opposite over the hypotenuse. So in this case, it was our y value over 1. Cosine was our adjacent over hypotenuse, so x over 1. Tangent, or the TOA, was the opposite over the adjacent. And so the opposite is y relative to this theta. The opposite is y, and the adjacent is x. So it's going to be the y over the x. Another way to think about this is kind of as your first trig identity. So the other way to think about this is that the tangent of theta, maybe add this to your word wall, is also equal to the sine of theta, the opposite value, the y, over the cosine of theta. So if you know your y and your x, your sine and your cosine, you can just divide the two values to find it. So since we now know how to find sine and cosine for any angle because of our unit circle, or not for any angle, for a lot of these common angles, the 30, 60, 90, 45s, all of those multiples, can we use those now to find tangent of those? So again, we got to draw them, we got to find the sine and cosine, and then we got to do a little bit more math with this. So let's draw the picture and kind of go from there. So how do I find tangent for different angles? Same way we started off. I'm going to draw in my angle. So where is 60 degrees? You either can find it on your unit circle or draw a quick example here. This is the 60. I know right away, again, this is going to be 1 for my hypotenuse. The x value here is going to be the smaller one, so it's going to be 1/2. This one's going to be root 3 over 2 from my special right triangle property. So I have that cosine is 1/2, sine is root 3 over 2. Those are my coordinates on the unit circle. And so the tangent of 60 degrees is equal to root 3 over 2, the sine value, divided by the cosine value, root 3 over 2 divided by 1/2. And so again, I wrote these out separately like this because division of fractions is really multiplication by the reciprocal. So root 3 over 2 times 2 over 1. Thank goodness that's going to simplify. The 2's divide out, and I'm left with just root 3. So the tangent of 60 degrees is equal to just root 3. Okay? So root 3 is going to be a common number that pops up because we saw root 3 over 2, 1/2, root 2 over 2. These are the numbers we're generally dealing with. And so we'll keep seeing them pop up more and more and more. So let's take a look at another one. So over here, I've got tangent of theta for theta equals 5 pi over 4. Let's go ahead and draw a picture of that. That's 1 pi over 4 more than pi. So when I go to draw my angle, it's going to go past pi and pi over 4 more, so that's halfway in between. There's 5 pi over 4. Again, so I realize pi over 4 is like 45, so this is my 45, 45, 90 triangle. This is 1, and my coordinates here are going to be root 2 over 2's, so negative and negative because I'm in quadrant 3 over here. So I know my sine of theta is negative root 2 over 2, and I know my cosine of theta is negative root 2 over 2. So or opposite over adjacent, same idea. So tangent of 5 pi over 4 is equal to negative root 2 over 2 divided by negative root 2 over 2. Some of you might see the answer already, but negative root 2 over 2 times 2 over root 2, still negative there, is going to wind up being the 2's divide out, the root 2's divide out, negative times negative, positive 1. So the tangent of 5 pi over 4 is equal to positive 1. That was very nice and convenient. Okay. Let's keep rocking and rolling. I'm going to go down to 450 degrees. Let's draw the picture in, find the sine and cosine, and then divide them. So 450 degrees, that is 360 degrees plus another 90. So as I draw that in, 360 plus another 90. That means on the unit circle, I'm landing up here at 0, 1, right? So the tangent of 450 degrees is equal to the sine of 450, which is 1, the y value, divided by 0. Uh-oh, we can't divide by 0. So the tangent of 450 degrees is undefined or does not exist. Okay, that'll be interesting when we start to graph stuff like that. But if you're dividing by 0, that ratio doesn't exist. Remember, the triangle doesn't even have opposite and adjacent sides when you really think about it. So it's kind of a neat thing. If it was the opposite effect, if it was 0 divided by 1, then the value would be 0. So 0 divided by 1 is 0. 1 divided by 0, undefined. So make sure you're careful with those as you go through it as well. I'm going to skip ahead to the next page, try another example as well. And then if we need more worked out examples at the end, you can go ahead and watch some of those as well. I'll give you a clue of when you can stop the video. Okay, here's the last example, 3a. I'm going to find the tangent of 7 pi over 6 for you. And then from there, you're probably good to pause and try some of these on your own, and then what I'll do is I'll just let you stop the video, but if you want to come back, probably the next several minutes of the video, then after this, we'll be working additional examples only if you need them. But again, most people should be able to kind of catch on at this point. So if we've got 7 pi over 6, I'm going to quick draw it. Now, you could just look up the sine and cosine values of 7 pi over 6 on your unit circle and go ahead and divide them if you're looking to save time. But again, I want you to get a sense or a feel of where these angles are coming from. So 7 pi over 6 is just over pi. It's 1 pi over 6 more than pi. Pi over 6, of course, is my reference angle, or 30 degrees, when you really think about it that way. So this, again, is acting like a 30, 60, 90 triangle with a hypotenuse of 1. The x-coordinate is going to be the bigger side, so the bigger side is definitely that root 3 over 2, and it's going to be negative because I'm going to the left. And the y value is down, so it's that smaller value of negative 1/2, because those are the values from my 30, 60, 90 special triangle. So now I know the sine of 7 pi over 6 is negative 1/2. I know the cosine of 7 pi over 6 is negative root 3 over 2. You could have looked that up on your unit circle. So therefore, the tangent of 7 pi over 6 is equal to the sine divided by the cosine. So negative 1/2 divided by negative root 3 over 2. And so as I start to kind of get down to simplifying these, that becomes negative 1/2 times negative 2 over root 3. And so as I look at those, the 2 divided by the 2 is going to divide to 1. Negative times negative is positive, so I wind up with 1 over root 3. But as we've talked about before, some people could say tangent of 7 pi over 6 equals 1 over root 3. Technically, a lot of books and a lot of things want us to require to get the radical out of the denominator. So really quickly, we're just going to multiply by 1 in the sneaky form, root 3 over root 3. And so then I get root 3 on top. Root 3 times root 3, of course, is regular 3. Now I've got it out of the bottom. So the tangent of 7 pi over 6 is positive root 3 over root 3. Why positive? Because it's a negative divided by a negative. It's going to be positive. So you can even kind of predict some of those things as they're happening. So again, tangent is all about finding the sine and the cosine and dividing them. The opposite divided by the adjacent. And we already know the opposite is our sine value because our hypotenuse is 1, and the adjacent is our cosine value because our hypotenuse is 1. So hopefully that gives you a good overview of how to find sine, cosine, and tangent of all the angles that would end on our unit circle values. We're going to talk about things that aren't on our unit circle on Thursday. So you can go ahead and pause the video or stop here. If you'd like, I'm going to spend maybe another few minutes in a different video covering more examples, but we'll go ahead and stop from there. Thanks. Stop by the office hours at 10 a.m. or 12 p.m. For any extra help, or if you want to set up something one-on-one, go ahead and email me as well.